right, so problem 2 is simplifying a rational expression containing a trinomial. And I tell you guys, this is my favorite because it has to do with factoring trinomials. So it says here, what is a simplified form of the expression? And we want to, of course, state the excluded values. Now, of course, because we have a trinomial in the denominator for letter A, we cannot state the excluded values until we factor our denominator. So let's see here. When we factor, okay, let's say we're going to have a, well, we can factor a 2 out of the numerator. So it's going to be 2 times the quantity x minus 4. That one's a simple one, right? Now, the second one, or the denominator, we're going to have 2 binomials. Okay, we have x times x. We know that's going to be our first, our A. And then, if you'll notice, we have to, when we multiply, we have to get a negative 8. And when we add, we want to get a negative 2. So when we multiply, and you should, eventually you'll be able to do this in your head. When you multiply, you want a negative 8. And when you add, you want to get a negative 2. So that means that you're going to have a positive and a negative. A positive and a negative, so you can get a negative number when you multiply. And you need to, the bigger number has to be negative because you want to, when you add, you want to get a negative answer. So here, the numbers that we're going to multiply to get 8 are 2 and 4. Okay, that's the part that you can do in your head because the number is so small. So here, we want the bigger number to be negative and the smaller number to be positive. And let me just give you a little hint here. If you have a problem like this, chances are one of them is going to be a negative 4. Okay, so when we put these numbers in here, we have x plus 2 and x minus 4. So now we can cancel out. So we can cancel out the x minus 4 and the x minus 4. Oh, before we do that, sorry, before we cancel those out, let's take a look at our excluded values. So here we know, so when we find our excluded values, you can see here that x, if we have to set each of these binomials equal to 0. So x plus 2 cannot be equal to 0 because if this whole thing is 0, then 0 times anything is 0. So we don't want that whole thing to be 0. Also, if this whole thing is 0, then 0 times anything is 0. So that cannot be equal to 0. So that's why we have to set each of the binomials equal to 0. So x cannot be equal to negative 2. And x cannot be equal to 4. And of course, you could have done that in your head. I mean, the subtracting on both sides and all that stuff. But it's always good to show your work. So these are your excluded values. Okay, and again, all you had to do was set each of the binomials equal to 0. So these are excluded values. So now we can go ahead and cancel the x minus 4 and x minus 4, and then your final answer is 2 over x plus 2. Final answer. Now let's take a look at problem B. Now problem B, the trinomial is in the numerator. Still, we need to simplify, okay? If we look at this, what number can A be? What number can A not be? Well, if you can't figure it out, you just set that equal to 0 for your excluded values. So, 3a minus 3 is equal to 0. Add 3 on both sides. So 3a equals 3. 3a is equal to 3. Divide by 3 on both sides. And yeah, I know, you could tell me that. A is not equal to 1. So there's your excluded value. Oops. excluded value. Okay, so a cannot be equal to 1. So now we can go ahead and factor our numerator. And again, using our x method, okay, when I multiply, I want to get a positive 2, and when I add, I want to get a negative 3. Well, of course, you know the factors of 2 are just 2 times 1, right? 2 and 1. So in order for us to get a positive 2, they both have to be negative. So negative 2 times negative 1 is positive 2. And then, when you add them, negative 2 plus negative 1, that gives you negative 3. So, we know that our binomials, let's just go here like this, the numerator is going to be a minus 2, and the denominator will be a minus 1. And that, of course, will be over 3a minus 3. Well, I don't see anything that can cancel here right now, but I can see that there's a 3 here, there's a 3 here. We can factor that out. So when we do that, we end up with 3 times a quantity, a minus 1. Well, bingo, look at that. So here we have a minus 2 times a minus 1 in the numerator over 3 times a minus 1 in the denominator. And now a minus 1 will cancel, and our final answer is a minus 2 over 3. All right, so let's take a look at problem C. And problem C, again, is the same thing. We want to do some factoring. We have a trinomial in the denominator, so we're going to want to factor that trinomial. Now, if you'll notice, this is in the form ax squared plus bx plus c. Since there's that a in the front, then that means that we have to use the AC method when we factor, okay? And you guys should know how to do this. We just tested on it. So let's figure out what our factored form would be, okay? So first thing we want to do is our AC method. So A times C, that's 2 times 6, that's 12. So we want to find the factors of 12. Oh, no, we're not using the X method. We're using the AC method. Let me erase that. So that means that, let's look at our factors. So we have 1 times 12, 2 times 6, and 3 times 4. Well, these obviously are the factors we're going to use for our binomials. Okay, so we're going to rewrite that. So using the AC method, we want to rewrite that 7z as 3z and 4z. Okay, so we've got 2z squared. Let's do plus 4z plus 3z plus 6. Does everybody see why I switched those around? Okay, because I know I had a 2 here, so I put the 4 there. And the 3 here, so I put this, and I had the 6 here, so I put the 3 with that one. So when I group, I can factor some stuff out. I guess, you know, it doesn't really matter because you're still going to be able to factor some stuff out, but I like to actually see the factoring. Okay, so when we factor in the first one, we're going to factor out a 2z. Okay, so 2z factors out. We're left with z plus 2. Right? And then when we factor out a positive 3 in the second one, so plus 3, we end up with a z plus 2. So my two binomials will be those two and that. So we've got z plus 2 times 2z plus 3. So now we have our binomials. Now we can figure out what our excluded values are going to be. Okay? So let's look to figure out what our excluded values will be. So here we have z plus 2 cannot be equal to 0. So when we do this, subtract 2 on both sides, z is equal to negative 2. So we know that z cannot be equal to negative 2. Then we have 2z plus 3. That cannot be equal to 0. Okay, I have to write this down. So subtract 3 on both sides. We end up with 2z is equal to negative 3. Divide by 2. So z cannot be equal to negative 3/2. Leave it as an improper fraction. So these are the excluded values. Okay, those are our excluded values. So now we can go ahead and start factoring. So let's see, we've got 6z plus 12 over, I'm going to go ahead and write my two binomials here. So that's going to be z plus 2 times 2z plus 3. Now, can I factor something out up here? Well, yeah, we can factor out a 6, right? So we factor out a 6. We're going to end up with z plus 2, right? So when we do that, let's see here. Let's scoot that over a little bit. And look, so tricky. So we have 6 times quantity of z plus 2, z plus 2, 6 times quantity of z plus 2 over z plus 2 times 2z plus 3. So now you can see that we do have some canceling going on. We're going to cancel the z plus 2's, and then our final answer will be 6 over 2z plus 3. There's your final answer. Okay? And you know what? It would help if you say that this is your factored form, and then you can say my excluded values are z is not equal to negative 2 and z is not equal to negative 3/2. Okay? So you could also do that up here. You have your final answer here, and then you can say excluded value is a not equal to 1. And then your excluded value is here, same thing. Okay? All right, so let's do problem D. Okay, so for problem D, if you'll notice, you have two trinomials, one in the numerator and one in the denominator. And we're going to go ahead and factor both of them. Okay? So here in my numerator, I have, I'm going to end up with two binomials, and c squared is rewritten as c times c. 6 will, let's see, we've got 2 times 3 and 1 times 6. So 2 and 3 are the numbers that I'm going to use, okay? 2 and 3. Now we know, let's see, we want one to be positive and one to be negative, because when we multiply, we want negative 6. We want the bigger number to be a negative, because we want to, when we add, we want to end up with a negative number. So that means it's going to be a negative 3 and a positive 2. See how I talked myself through that? And I didn't even have to show that factoring work. Okay? Same thing with the denominator here. And if you need to show the work, go ahead and show the work. Okay? We know that c squared, again, is c times c. We're going to have 1 times 2 again. I'm sorry, 1 times 6 or 2 times 3. And let's see. We want a positive. So we're going to have, let's use, we're going to have to use 1 and 1 and 6 or 2 and 3. Negative, negative. No, positive, no, we're going to use 2. We're going to use 2 and 3 again. So 2 and 3. So here, when you multiply, you want to get a positive 6. So they either have to be both negative or both positive. So here, because when we add, we want it to be positive, then we want them both to be positive. Now, do you see what we can cancel out? Doink, doink, right there. Okay, so our final answer is C minus 3 over C plus 3. Uh-oh, we forgot to do our excluded values. So let's go back. Now, we don't want to use our final answer for our excluded values. We want to use our original denominator for our excluded values. So C plus 2 is equal to 0, and C plus 3 is equal to 0. So subtract 2 on both sides. C is equal to negative 2. Whoops. C is equal to negative 2. Subtract 3 on both sides. C is equal to negative 3. So here, those are the excluded values. Okay? So you can go ahead and rewrite those right there. You can write, this is my final answer for C is not equal to negative 2, and C is not equal to negative 3. And that's it.